Hi everyone. In this week of material, we are going to be talking about quantitative and qualitative data analysis. Now, we're not actually going to be doing any data analysis, but there's a couple of terms with which you should probably be familiar. If you think back to the first couple of weeks of class, remember the purpose of studying research as master's students, the purpose that we talked about was to learn to appraise research. Your task here is not to become proficient researchers. It's really to become informed consumers of research. To learn to become a researcher actually takes an incredible really an incredible investment in time. And part of the time that you spend learning to become a researcher is spent learning how to do data analysis. So oftentimes people study, quantitative or qualitative or both data analysis for a couple of semesters, and we're only covering it here in a week. So again, the key here is that you've heard of a couple of terms, you're familiar with a couple of key things. We're not actually going to be doing any of the analysis. Before we get started, quick review. Quantitative versus qualitative. Quantitative uses numbers as its data source. Quantitative converts social phenomena to numbers. That's what we've spent the entire, most of the semester thinking about and learning about here. Qualitative uses words or sentiments, phrases, as its data source. And it is important that you understand the distinction. So that's probably something I would ask about on an exam. Why do we care about the distinction between quantitative and qualitative? Well, a lot of it has to do with what kinds of judgments we can make about the world. So in the quantitative tradition, in the quantitative orientation, if I can reduce or convert every single person's experience about a particular phenomenon to a number, my assumption is that there is one reality of the world that can be represented by numbers. It's a perfectly valid assumption. Some people would challenge it though, and so qualitative research emerged as sort of a counterpoint to this idea that there's only one true reality. Qualitative researchers tend to think that the world is a pretty subjective place, that there are multiple realities, that there are multiple experiences that are all equally as valid as any of the others are. And so in order to study that, we have to look for some data source other than numbers, and we do that through words or sentiments, phrases, that kind of thing. So again, the distinction here is kind of important, and as I said, I'm likely to ask a question on an exam about the difference between what quantitative research uses as its data source and what qualitative research uses as its data source. So in quantitative research, we use essentially three levels of statistics. We're only going to cover the first level here. Some descriptive statistics. Descriptive statistics describe the data. They don't really look at the relationship between any two variables. They're just looking at one single variable. So we could look at the frequency, which is the number of times a particular answer is endorsed. We could also look at a measure of central tendency, and the three examples that I'll give you here are the mean, median, and the mode. The mean is the average, the median is the number that occurs in the middle, and the mode is the number that occurs most often. So for example, you could take the age of a population. Maybe there's 100 people, in a given population of people. We could look at how many people are, 10 years old, how many people are 11, how many people are 12, so on and so forth. That would be a frequency distribution. If we took the average age, that would be the mean. If we lined up all the ages from youngest to oldest and picked out the one that was in the middle, that would be the median. And if we picked out the one that occurred most often, that would be the mode. A measure of variability is simply the difference between the lowest score and the highest score. So if in our given imaginary population of 100 people, the youngest person was 10 and the oldest was, let's say, 70, the range would be 60. It's simply the difference between the highest answer and the lowest answer. Standard deviation is not anything that you necessarily need to know. That's how the scores arrange themselves on a normal distribution. Lots of variables that we're interested in are typically normally distributed. Scores on measures of psychopathology tend to be normally distributed. Height tends to be normally distributed around some average. Income tends to be normally distributed in a community. There's a few exceptions, that kind of thing. But standard deviation is simply converting all of those to a standardized function, and then you look at how far it falls from the mean. It's okay if you don't know what a standard deviation is. I wouldn't ask about that on an exam. There are then this sort of second level of things called inferential statistics, and these are statistics that typically they require two variables in order to look at them. So there are statistics that determine association, and two of those statistics are a chi-square and a correlation. You may have noticed that if you wrote correlation in a paper, I often say something about that because correlation is actually a measure of linear association. I don't expect you to know that. I wouldn't test you on that kind of thing, but correlation actually has a very specific meaning. And it's, like I said, it's a measure of the linear association between two variables. There are lots of variables that don't actually have a linear association. So don't use the word correlation in your papers, use the word relationship, because that's oftentimes what you mean, and relationship, frankly, is a much better word for it. Then there's a group of statistics that help us determine differences, and these are usually classified as t-tests or ANOVAs. And so to do either one of these, we have to compare the score of one group to the score of another group. Say, for example, we wanted to compare, the average age of one community to the average age of another community. We could do that with an independent samples t-test. T-tests look at the differences between two groups. When we start to get into what's on the slide here is one-way analysis of variance, but is also called ANOVAs. That's when we start to look at three groups or more. And we often do that because in intervention research, we might be comparing the scores across 3 or 4 different arms of a study. So if you think back a couple of weeks ago to our research design lecture, ANOVA is often the statistic used to evaluate group designs in which there's multiple conditions. All right, let's move into qualitative data analysis. In qualitative data, so you've recorded your interviews or your focus groups. You've spent the time to type up those interviews, or you've paid someone to do it. That's extraordinarily expensive. And actually a big help because it takes a very long time to type up interviews. After they've been typed up, you've checked what's been written against what's typed, or what's been typed in the transcript, and corrected any errors. All of that takes weeks and weeks and weeks, or just sort of incredible amounts of time and money. So that's what step 1 means: preparing your data in transcript form. But then you have to choose a method of analysis. Who's going to do those those transcriptions. You have to take into account those ethical issues. If you're hiring out your transcription, is this a firm that has sort of confidentiality in place? Do we need to alert the IRB? If it's a researcher or a colleague or a student or something like that doing it, same thing. Are they taking all the ethical issues into account? Then you actually do the transcription. You might check it, like I said, but after that, you're establishing a plan for the data analysis. And typically, people establish a plan. They know how they're going to analyze the data before they actually even collect it. So you can preview it. Qualitative researchers will often keep a journal, which is simply a record of their thoughts, the reactions that they have to the data that helps them develop insights into the data. And then what you're doing is what's called coding. So in coding, what you're often doing here is, let me just get all these up on the screen here. What you're often doing here is going line by line through the transcript and highlighting or circling or making notes about words that are useful, or words or phrases that are useful. So, for example, you might go through a transcript and identify all the meaning, all the emotion words, right? So you might identify them. And then you might create a second level of codes which groups emotions that are similar into the same category. So you might have positive emotions or negative emotions, or you might have, there's even ways to sort of subdivide that. There's hopeful emotions, there's happy emotions, there's grateful emotions. There's ways to sort of categorize negative emotions as well. There's anger. Sort of anger and frustration. There's despair, and so what you're essentially doing though is creating these categories until they sort of merge into something that's meaningful, which is sort of your explanation for the data, and that's really when you get to that place where you're starting to merge the categories or develop a way to classify or explain all of the categories that you've developed. That's really step 5, which is this idea of theory building. And so your way of explaining all of the sort of different kinds of categories and the way they're lumped together and stuff like that is in essence your theory. After you typically have developed this explanation, this theory for the data, the next step is to assess the trustworthiness of your results. And there's a couple of different ways that you can do that. You could check with participants. You could check with other experts. You could check with other researchers, or you could often check with both. So in some of the qualitative research that I did, and I'm predominantly a quantitative researcher, but I have done some qualitative stuff. So we had a team of, I think there were 7 of us on this team that wrote a couple of these qualitative papers. And there were 2 of us responsible for analyzing the data. Well, what we did is we went through the process. We went through sort of steps 1 through 5. And then we actually put together a presentation, and the 2 of us delivered this presentation to the other 5 members of the research team, who then, criticized it, sort of tried to poke holes in what we did, and gave us feedback. We then took all of that, sort of refined our interpretations and the sort of theory that we'd come up with to sort of explain the data, and we did that a second time. And then we actually started to write the paper. All of this is to say that it took a very, very long time. And qualitative research, sort of one of the hallmarks of it is that it's very time intensive. But it's very time intensive because your goal as a researcher is really to develop a deep understanding of your participants' world, and that gets back to that idea that there's multiple realities and multiple viewpoints. So, as I said, that's the brief overview of qualitative and quantitative data analysis. Remember that what you should know is the difference between qualitative and quantitative, and what the view that each one sort of takes of the world. So quantitative data or quantitative research sort of believes that there's one objective reality, and we can represent that objective reality through numbers. Qualitative research recognizes or challenges that quantitative assumption and says, nope, there's multiple realities. Reality is subjective, and the only way to really represent reality is through a person's own description of what their reality is. So qualitative research uses words and phrases as its data source, because you're representing someone else's reality. All right, any questions? As always, feel free to get in touch. Thanks for watching.